There is an object in our universe that shouldn't be possible. It's smaller than a city. You could walk across it in about 20 minutes. And yet, in the year 2004, something happened on this object that reached across 30,000 light years and touched the Earth. Not with a spacecraft, not with a signal, with a flare of light so powerful, it disturbed our planet's atmosphere from a distance almost too large to imagine. This is the story of that object, and of a question scientists still can't fully answer. What is it? And why does it exist at all? To understand it, we have to start somewhere familiar. With stars. Most stars spend their lives in balance. Gravity pulls inward, fusion pushes outward. For billions of years, it's a standoff. But some stars are too massive to hold that balance forever. When they run out of fuel, gravity wins, the star collapses. Not slowly, in an instant, and what's left behind is strange. It's called a neutron star. Imagine taking something the mass of our sun and crushing it down to the size of a city. A teaspoon of it would weigh about 1 billion tons, more than every human being on Earth combined. That alone should be the strangest object in the universe. But it isn't, because some neutron stars are different. Some of them have a magnetic field so powerful, it defies the imagination of the people who study them. 1,000 trillion times stronger than Earth's. Scientists call it a magnetar. And once you understand what that field can actually do, you start to understand why this isn't just another star. It's something closer to a warning. For a long time, magnetars weren't even believed to be real. In 1979, instruments across the solar system picked up an intense burst of radiation. It lasted a fraction of a second. In that fraction of a second, it released roughly as much energy as our sun does in 1,000 years. Nobody knew what caused it. For almost 2 decades, it stayed a mystery. Then, in 1998, astronomers finally confirmed it. A neutron star with a magnetic field beyond anything known to exist. The magnetar was real, and it turned out to be far more active than anyone expected. In December of 2004, one of these objects did something remarkable. A magnetar called SGR 1806-20, sitting on the far side of our galaxy, released a flare of energy. In just 0.2 of a second, it let out more energy than the sun produces in 250,000 years. That flare crossed 30,000 light years of empty space and reached us. It saturated satellite instruments. It bounced radiation off the surface of the moon, and it measurably disturbed the Earth's upper atmosphere. From an object we will never see with the naked eye. That's not fiction, that's recorded data. And it's only the beginning of what makes these objects strange. Because in 2013, astronomers found something even harder to believe. A magnetar, sitting almost directly beside the supermassive black hole at the very center of our galaxy, close enough that its own magnetic field is now helping scientists study the black hole itself. 2 of the strangest objects in the universe, sharing the same small patch of sky. Then, in 2020, something happened that solved a mystery going back over a decade. Since 2007, astronomers had been detecting brief, powerful flashes of radio waves from deep space called fast radio bursts. Nobody knew what produced them. Then, in April of 2020, one came from inside our own galaxy, and for the first time, it was traced directly to a magnetar. A decade-long mystery in astrophysics, quietly solved by a star we already knew about. And most recently, in the past year, scientists confirmed something even stranger. Near a magnetar, empty space itself starts to behave differently. Light passing through the vacuum around it splits, depending on how it's polarized. Something predicted by quantum physics almost a century ago, but never actually observed. Until now, near a magnetar, nothing isn't quite nothing anymore. So what would happen? If one of these objects came close to us, we don't have to guess entirely. We have real data. The 2004 flare disturbed our atmosphere from 30,000 light-years away. If a magnetar were only a few thousand light-years closer, a similar flare could seriously damage our ozone layer. At a close enough range, within a few thousand kilometers, its magnetic field would begin to distort matter itself. These closer estimates are less precisely measured than the 2004 event, but they follow the same physics. The good news is scale. The nearest known magnetar is safely tens of thousands of light-years away. There are only around 30 known in our entire galaxy, but scientists estimate there could be 30 million more. Quiet now, their fields faded, their fury spent, scattered across the Milky Way like extinguished lanterns. We simply can't see them anymore. Here's what makes this stranger than most explanations admit. Scientists don't fully agree on why some neutron stars become magnetars, and most don't. One theory says it depends on how fast the star was spinning when it collapsed. Another suggests some stars are simply born with unusually strong fields already. And in 2010, astronomers found a magnetar with a magnetic field too weak by their own theory to behave like one at all. It behaved like one anyway, which means the very definition of a magnetar is still being rewritten. We didn't stumble onto this object and immediately understand it. We're still catching up to it. Every few years, it teaches us something new about magnetism, about the vacuum of space, about the outer edges of physics itself. Somewhere in our galaxy right now, there are city-sized objects spinning quietly in the dark, holding magnetic fields that could unravel the atomic structure of anything that came too close. We are not near one. We are, by every measure, safe. But it's worth sitting with the fact that something this powerful, this strange, has existed this whole time, close enough once to leave a mark on our own atmosphere, far enough away that we never even felt it happen. The universe rarely announces its strangest secrets. Sometimes it just leaves a signature and waits for someone curious enough to go looking for it.